In this lecture, we'll play around with the SD card. I'll show you first how to use the SD card as a place to store sensor data. I'm also going to show you how to use the SD card so that your Arduino and your Linux computer can work and interact with each other. So I've already got my board booted and I've got the SD card inserted, and I'm just going to go to my Arduino examples and pick a very simple one. Start with SD card for Galileo, and let's try out the data logger. The data logger example, what we do, basically the first few bits are standard for any Intel Galileo Arduino sketch that wants to use the integrated SD card, because you have to use the chip select number 4 in order to initialize it. That's where the integrated SD card will listen for. It's an SPI device. If you wanted to have another SD card connected to your Arduino, you can use one plugged as a shield, and that should be configured to listen to another SPI address. So for the integrated SD card, the SPI address is 4. So what we do in this sketch is we grab readings from the analog pins, and then we store these readings in a file on the file system on the SD card in a comma delimited format. I'll just go ahead and upload it. Okay, so now let's see, where is the data logger file? If we go to media, and in here we've got several directories. One of them is real root. Go inside real root and have a look in here. We'll see that we've got a new file, the datalog.txt file, which is the file in which we write the rows with the values from the sensors. We have a look inside this file using the cat command. You will see that we get values from our sensors, basically a comma delimited set of rows. So then you can stop that here. You can copy this file from your Arduino to a computer and do some processing in Excel or in some other data analysis package. But that's as simple as it gets. You can store data inside a text file using your SD library specifically designed for the Arduino Galileo. Let's have a look at another simple example. In this example here, just make this window a little bit larger. I have a very simple sketch that makes use of the system command. The system command allows you to execute Linux commands like this command here from inside your Arduino sketches. There's no way for a system command to return any values directly to the Arduino side and to your Arduino sketch. So I can't do something, for example, like this, int a, execute the system command and the system command to return an integer, and then to be able to do something with the value stored in the a variable. So this is not possible. What is possible though is to get Linux to execute a command like this echo command, and then use this operator to store the value or the outcome of whatever that command does to a text file. And then for my Arduino sketch to go to this location where the text file is stored, open up the text file for reading, and then extract the information from it and continue with its processing. So I'll show you what this echo command does first. Just copy this part and just paste it directly into Linux, and you see that this echo command, all it does is to open up this file here. Just going to do even this part separately. Just say cat. Sorry, cat is already in there. So this is just a simple text file, and in it, Linux will store the core temperature on the integrated circuit on the chip. So this essentially is the temperature of the CPU at this point in time. And because I want to convert this into degrees Celsius, I will divide by 100 and it will give me 67. So 67 is the degrees Celsius temperature of the CPU at this moment in time. Because I can't return this number directly to my Arduino sketch, I have to store it in a temporary text file. So if I do this whole thing, so I'm going to copy this part of the system command from the sketch and paste it to Linux, then I'm going to go next to home and root, and in here you'll see that there's a brand new file that contains the number 67. So the temperature is stored in this temp.txt file, temperature.txt, at a location that I can control as well, so it doesn't have to be the location that I've got included or displayed in this example. Then from here, I'm just going to open up the file, extract this number, and print it in the serial monitor. So I will upload the sketch and see what happens next. All right, and then have a look at the monitor, and there you go. The value 67 was read from the text file, from this text file, and returned to the Arduino side. I'll just stick my finger on the processor to cool it down a little bit. You can see that now 59 degrees, my finger's getting really hot. So can use that as a touch sensor as well, back to 64, 65, etc. So this is a unique feature on the Arduino Galileo, the ability for the Linux side and the Arduino side to communicate with each other using this system command inside your Arduino sketches to execute something on the Linux side, then use a temporary text file as a conduit for data to flow from the Linux side to the Arduino side. Okay, so there was a quick demonstration of what you can do with the SD card from the perspective of your Arduino sketches. In the next lecture, I will play around with LCD screens that normally are used with my Arduinos and see how those work with the Arduino Galileo.